Okay, good morning. Welcome to
FamilyMath number 710.
FamilyMath number 710. And so yesterday we were driving somewhere, and I just happened to have this book in the car. And so I had you open up to random pages, and we talked about some of the ideas. And one of the things you opened up to was, I don't know if it'll show up on screen or not, but it was Newton's method for root finding. Right?
Yeah.
And that turns out not to be the easiest thing to talk about in the car when you're driving, but I thought we'd talk about it for a project today. And I'm not going to go into all of the detailed math because it involves calculus and a little bit of algebra that complicates the situation. But what's actually happening in Newton's method isn't all that hard to understand the idea. And it turns out, I'll just say, it turns out that the math and the calculus and the algebra simplifies things actually incredibly, and the actual formulas for doing this are really easy. So, for Newton's method, what you're trying to do is you're trying to find roots of an equation.
Alright.
What are roots of an equation?
Where the y value is 0 when you graph the equation when the y is 0.
Okay. How would you define roots?
I'd say where they just cross the x-axis. It's some equation where it crosses the x-axis.
Okay. Yeah, and sometimes for any kind of equation you're trying to solve, if you have a function f of x equals some value, 7, well, now you're not looking for where it's 0, but where it's 7.
Yeah.
But what function would be 0 where this function is 7?
Well, there's no values where this way. That means 0 would have to be equal to 7.
Well, what new function g of x equals 0 when this function equals 7?
I'm not sure I understand.
Okay. How would I find if I knew this function equaled 7 and I need this function equals 0?
Well, you just take whatever you did to x and you subtract 7 to it.
Right. So this function is just going to be f of x minus 7. That's going to be what g of x is.
Yeah.
So that's why we talk about finding zeros. Because if you want to talk about finding something else, you just subtract it away.
Yeah.
And then also finding zeros comes in useful when you're factoring. But anyway, that's why we talk about zeros a lot. What are the kinds of functions or equations that you know how to solve? Or how to find where they're zero?
Like linear equations and
Lines.
quadratic equations.
Okay, you know linear and quadratic. Have you ever heard of the quadratic formula?
Somewhat.
You've heard of it.
Yeah, perfect.
But for general functions, there's no rule. In fact, even for polynomials, there's no rule above for fifth degree polynomials or higher. And so what Newton came up with is he said, say we're trying to find a root, and we know it's somewhere like around here.
Yeah.
Because maybe we know the function's below 0 here and above 0 here, so and it's a nice, smooth, continuous function, so we figure it's got to pass through 0 somewhere. So what Newton says is we'll just take a guess. We'll take a guess at it's 0 here, and then we check the value of the function. So we plug in the value of the function that takes this x value up to this y value. Okay, and we say, is that 0?
No.
No. Right?
It's not 0.
It's not 0. And then what Newton said is what we'll do here is we'll pretend this function's a line here. It's not really a line, right? But there's something called a tangent line to that function.
Yep.
And you learn how to find that tangent line in calculus, actually. So that's where the calculus comes in. And Newton knew how to do this, because why?
He knew calculus.
Yeah.
Well, he invented calculus.
Yeah, he invented. He was one of the people who invented calculus. So he said, so what do you notice about this tangent line in its relation to the root?
So it's pretty close to the root.
Okay.
Yeah.
So what do you think happens when I follow the tangent line down and find where the tangent line is?
Well,
0?
then you
can
do
do
this
that
again.
again.
You get the point. You get the x value, what that is, then you find that tangent line
Okay.
to that.
Is that 0?
It's
No.
not.
No.
But it's closer
It's
to
better
0.
approximation.
Close to 0. So I go down here.
And then you can do it again.
And then it just spirals into 0.
Yeah. So that's actually pretty cool, right?
Yeah.
Yeah.
So it seems like actually a great idea that hey, we don't know where the function is 0. But maybe we can have a good guess. And once we take that guess, we just check if it's 0. If it's not, we follow the tangent line. Either down, or if you're if you're below, you can follow the tangent line up.
Yeah.
And then you continue that process, and it seems like you converge into the 0. Do you think you'll ever actually get there perfectly?
No, but you'll get.
You'll get
If you
it.
did like.
You get it pretty good.
If you did this 10 times, you're gonna get a pretty good approximation for what the root is.
Yeah. Yeah, probably. All right, so let's talk about some problems that might come up, because this is, first glance, it seems like it works really well.
All right.